So we need to determine whether matrix A is similar to matrix B, and if they are, we need to give an invertible matrix P such that P inversed times A times P equals B. So it can be observed that matrices A and B are diagonal matrices. So the eigenvalues are the entries on the main diagonal values. So we get that eigenvalues of both A and B. So eigenvalues of A and B are lambda 1 equals 1, lambda 2 equals 1, and lambda 3 equals 1. So A and B eigenvalues. Now we can obtain the eigenvector corresponding to agency's eigenvalues. So first, for eigenvalue lambda equals 1, we will solve for A minus I times x equals 0. So then our matrix A minus identity matrix times matrix X equals 0. So by doing this subtraction, we get 0, 1, 0, 0, 0, 1, 0, 0, 0 times x1, x2, x3 equals 0. This means that x1 is a free variable here, variable. x2 equals 0 and x3 equals 0. So if x1 equals 1, then v1 equals 100. Now we will obtain the eigenvector to the eigenvalue lambda equals 1, but for matrix B. So here we will have matrix B. Let me copy paste it. Matrix B minus identity matrix times x1, x2, x3 equals 0. So here we get 0, 1, 0, then 0, 0, 0, 0, 0, 0 times x1, x2, x3 equals 0. So here x1 is a free variable, x2 equals 0, and x3 is also a free variable. So if x1 equals 1 and x3 equals 0, then v1 equals 1, 0, 0. We will choose the arbitrary value x1 equals 0 and x3 equals 1. So 0, x3 equals 1. Then we get that eigenvector is v2 equals 0, 0, 1. So it is observed that the eigenspace corresponding to lambda 1 of a matrix B has dimension 2. So for B, eigenspace has dimension 2, but the eigenspace corresponding to lambda equals 1 for matrix A has dimension 1. For A, dimension 1. So this means that matrices are not similar. Not similar.